all I do is grow, grow, grow no matter what. Got growth on my mind, I could never give up. And every time I get that sinking feeling that makes me feel stuck, I just keep trying, I just keep trying, I just keep trying, I just keep trying. Alright, welcome to another math video with Ms. Jones. In this video, you'll learn about a 2-digit by 2-digit multiplication strategy that's using an invented math method which was created by a student. Before we dive into math, you know I like to do a joke of the day. So tell me this, riddle me this, riddle me this. Why did the chicken cross, I almost said road, but it's playground. Why did the chicken cross the playground, y'all? You thinking about it? I'm thinking about it. Let's see. Why did the chicken cross the playground? Well, pretty much I'm sure because it wanted to get to the other slide. Y'all get it? Just kidding, y'all. All right, let's go ahead and get into this math. So you might be wondering, well, hey, who invented this method? Well, during my first year as a math teacher, the ELA teacher, which is right here above me, she is very excited to share with me. But you can see she came to my classroom at the end of what was a long day, but she was excited to show me because she had been chatting with the 4th grade math instructor, and there was a scholar in the classroom that had invented a new math strategy to multiply 2 digits by 2-digit numbers. And let me tell y'all something. The rest is history. The rest is history. Let's take a look and see what the scholar invented, and then we'll get into how to perform the strategy. Here we go. Different strategy. Good. Okay, great. Yeah. Invented math is what we call it.
I'm going to see if I can do this correctly. She taught me this. All right, so what she does is, because she came up with this because she was having trouble multiplying.
Yeah, double digit. The standard algorithm.
So she does this.
Yeah.
Okay. She did 12 times 2.
Yeah.
Just 24, and then she put the 2 up here. Okay. And then she went, 12 times 1.
Yeah.
13, 14, 15. No, hold on. No. It's 12 times 1 is 12 plus 2.
It's 14.
That's 14. And she got the answer that way. And it works not only for this one.
No, it doesn't work for every.
It does.
No, now.
Okay.
In math, we have to prove that a strategy works for not just double digit. So, y'all, I was pressing this teacher to show me this strategy using other numbers because, you know, I wanted to make sure it was legit for all numbers. And I've proven that it does work for 2-digit by 2-digit, 3-digit by 2-digit, 3-digit by 3-digit. But what I also discovered is that the most efficient method, the most gains, the most benefits will be received by using a 2-digit by 2-digit method. I like to call this method the slide to the side. Let's take a look at it and see what this scholar created. Here we go. So we're going to start by multiplying 37 by 48, 37 times 48. And what I'll do is I'll model the traditional standard algorithm, and then I'll model that scholar's method, the slide to the side, and explain why I call it that after I model one. Then we'll do one more example, and maybe you can try some on your own. So here we go. Let me turn this camera on for you. Here we go. All right. All right, so first let's go ahead and take a look at that standard algorithm. And just to remember, the standard algorithm and this scholar's method is based on place value. The notation is different, but it is still essentially based on place value. So here we go. All right, so we have 3 10s and 7 1s times 4 10s and 8 1s, or 37 times 48. So I'm going to first start by multiplying my 1s times my 1s. 8 1s times 7 1s gives me 56. And if you know traditional math, we will bundle that 5 10s to the next place value to the tens place. So you can write it here. Or sometimes I like to write it here. Okay. So we have the 56, that's what 8 times 7 is. And now we're going to keep going. We have now 8 ones times 3 tens, so that's going to give us 24 tens, all right? 24 tens plus 5 more gives us 29. So I'm going to cross out this 5 that I bundled, and then I would essentially get 296. I can rewrite that. 6 is kind of large. 296 for my first partial product, okay? And now I'm going to go ahead and multiply my 4 tens times every digit in this factor, every place value. And I know that this is a 4 in a tens place, so what I like to do is go ahead and put a 0 here as a placeholder. That's what we're familiar with in the standard algorithm. Let's go ahead and multiply. We have 4 tens times 7 ones, okay? So that's going to give me 28 tens. I put my 8 in the tens place, and I bundle my 2 to the hundreds place. And then I'm going to keep multiplying. 4 tens, or 4 times 3, gives me 12 hundreds. 12 hundreds plus the 2 that I bundled gives me 14 hundreds. Now, I'm going to go ahead and add up my partial products. I should have 2 partial products because I have 2 digits in the second factor. 6 ones plus 0 ones gives me 6. 9 tens plus 8 tens gives me 17 tens. I bundle that 1 to the next place value, to the hundreds. 4 hundreds plus 2 more hundreds gives me 6 plus 1 more gives me 7 hundreds. Cross that out, and then I have 1,000 left. So my answer should be 1,706. 776. It will summer, y'all, at some point. The answer is 1,776. All right, so let's go ahead and look at her method. She starts the same way. Let's go ahead and multiply 8 times 7. That gives us 56. The only thing different is she only places down the 1 that's going to be, the digit is going to be in the ones place first. And then we're going to slide to the side all the other partial products. So we know that 8 times 7 is 56. So I would be bundling a 5 here. So 3 times 8 is 24 plus the 5. So I'm going to slide to the side. I'm going to put my 29 for the rest of my partial product here. Okay? And let's keep going. And then I'll continue. Now I'm going to multiply my 4 tens times 37. Again, I'm going to slide these partial products to the side and get my answer. I'm going to add them together. So 4 times 7 is 28. Put my 8 down. Bundle the 2. Now, 4 times 3 is 12 plus 2 is 14. Okay. Now I'm going to add up my 2 partial products and then just basically place them right here in front of my final product. 8 plus 9 is 17. Plus 1, 4 plus 2, 7. 1, so I take this, 177, and I'm going to go ahead and put it right back in my number, because essentially what this represents are the partial products. She just essentially broke them apart and wrote them visually on the side instead of writing them vertically here, because this was confusing to her. So she just slide it to the side. Slide the partial products to the side. Only thing you write down first is your product that's found in the ones place in this method, and then you add up all of your other partial products, and the reason they go right in front is because we've already written down the partial product for the ones place. Let's go look at one more example, see if we get the hang of it. Again, slide to the side. It's easier with simpler numbers, but you can also do it with more complex 2-digit by 2-digit numbers. Let's try another one. Here we go. Let me go ahead and change my slide. We'll flip this. Here we go. Our next example we're going to look at is 52 times 12. All right, here we go. Let's try. This time I'll try to do them together so you can maybe more easily compare. 2 times 2 gives us 4. 2 times 2 here gives us 4. And here's where we differ. In our standard algorithm, you're going to continue multiplying. 2 times 5, that gives us 10. We write it adjacent, and we have one partial product. Here, 5 times 10, we slide it to the side, and we wait to add the additional partial products over here. Let's keep going. The standard algorithm, I put a placeholder. Now I'm going to do 2 times 1 and 5 times 1. Okay. And here I would do 1 times 2, 5 times 1. Add these two together and add these together. It's just a different way to notate it. So here we go. 2 plus 0 is 2. 5 plus 1 is 6. So I would put my 2 and my 6. Say I would take this, put it right in front because this represents your tens and your hundreds. And in this case, I'm just going to add my partial products like I would normally do. And you can see that they check out. Okay. And you can see how this method could easily be pretty fast. Okay. It could easily be pretty fast. And so I want you to pick two numbers. It works for any number. And that's why this is a beautiful strategy. I want you to pick two numbers and try it yourself and let me know what you think. Okay, you can let me know in the comments, reach out to me, let me know if it works for you. And this is a great strategy if your scholar is struggling with 2-digit by 2-digit numbers, so they could have some success with that skill. So hold on just a second. I'm going to turn this one camera off. And I just like to say, you know, thanks so much for taking time to watch this video. And if nothing else, I'm hopeful that this, just watching this invented strategy, you'll encourage your scholars to take risks in math, to ask questions. The scholar, you know, just was not grasping the standard algorithm. Now, of course, that's a skill that at some point we're hopeful that scholar will master. But our brain is so incredible and is powerful, and scholars have the ability to do great things. And so I love that she created this, and I have used it quite a few times. And so let me know what you think. Thanks so much for watching. Stay curious about math. See you on the next math video.